Take weekly paper 8. Okay, weekly paper 8, question number 1. Weekly paper 8, question number 1, part B. Right. We are given k, k less than 3, greater than 0. And fx given. Fx is 3 minus k x squared minus kx plus 1. This way we are given fx, right? Asking, write down the discriminant of fx equals 0 in terms of k. Hence, find the range of values of k for the roots of fx equals 0 to be real, right? First one. Right, fx equals 0. Fx equals 0 means fx is this, no? 3 minus k x squared minus kx plus 1 equals 0. This is our fx equals 0. It is a quadratic equation now. Now its discriminant asking delta. B, x coefficient is a b minus k. It's perfect squared, no? B squared minus 4ac is the delta. Delta minus k perfect squared, b squared minus 4 times a means this 3 minus k. A, c is 1. This is what we get for delta. Now, when you simplify this, we get delta k squared here minus minus plus, right? 4k minus 12. This is what we get for delta. Now, what is asking there? Hence, find the range of values of k for the roots of fx equals 0 to be real. You know, the roots of a quadratic equation become real if the discriminant of that quadratic equation is either greater than 0 or equal to 0, right? Then you can write for real roots. For real roots, delta greater than or equal to 0, right? Delta is this k squared plus 4k minus 12 greater than or equal to 0. You can now factorize this. What are the factors there? Right? It's k minus 2 and k plus 6. Right. You know how to find the range of k for this inequality. What is the method? Draw a line like this. Equate this bracket to 0. We get 2. Equate this bracket 0, we get k minus 6. Here we have equal sign, then both this 2 and minus 6 we have to accept. Now, this is the interval 0 available. Now, we substitute for this k 0 here and here. When you put k 0 here, this bracket is minus 2. When you put k 0 here, this bracket is 6, minus 2 into 6. We get minus 12 in left hand side. Minus 12 greater than 0 is false. Understand? Therefore, this interval does not satisfy. Therefore, this is the interval that satisfies. This and this. Okay. Now, asking to find the range of k the roots to be real. This is a range of k for the roots to be real. But remember, we are given at the very beginning, the k, however, lies between 0 and 3. Therefore, all this range and this range, all you can't accept. Because we have to accept subject to this condition of range of k of this. So therefore, though this is the range of k, the delta greater than or equal to 0, in other words, the roots are real, right? Since k lies in this interval, we can't select all this range for k. Then, of this range of k, we have to select the part this. That in other words, for this and this we have to take what? Common range. Okay, right. So therefore, when I mark in a separate diagram, this and that both, you can see here 2 and more, and here minus 6 or less, like this. This we get. Now I am going to mark, this says k is between 0 and 3. K is between 0 and 3. Suppose 0 here, 3 here. There, k doesn't take both 0 and 3. So therefore, circle here and circle here. Now you can color like this here. Okay. Now we have to take what? The common range. What is the common range therefore? Yes? Without 3, including 2, no? Can it take 2? Yes, it can take 2. So therefore the common region going to be k equal to 2 or more less than 3, right? Then common region is that. Common region is the answer now, right? Common region. K less than 3, greater than or equal to 2. This is the range of k for roots to be real. If you write this only, your answer is wrong because you are given k lies in this interval. That is the reason, right? First part is okay. Second one asking, let the roots of fx equals 0 are alpha and beta. Write down alpha plus beta and alpha beta in terms of k. Show that when alpha and beta are real, then both of them are positive, right? Fx equals 0, right? This is the fx equals 0 quadratic equation. 3 minus k x squared minus kx plus 1 equals 0. Its roots are, one is alpha, other one is beta. Okay. Then sum of the roots you know, alpha plus beta. How do you write? Minus b. B is the x coefficient. It is minus k. Right? Then this minus and that minus make plus. Minus b divided by a. A means x squared coefficient 3 minus k. And alpha beta product. How to write alpha beta product? The constant term divided by the a. C over a. Right. It is 1 upon 3 minus k. Right. We wrote alpha plus beta and alpha beta in terms of k. Show that when alpha and beta are real, then both of them are positive. When alpha and beta real means the two roots are real, right? You know, when two roots alpha beta are real, we have just now proved k should be in between 3 and 2. K lies in the interval this. Okay. See here, when alpha and beta both are real, we proved just now k lies less than 3, greater than or equal to 2. You can very clearly understand when this k lies between 2 and 3, see here, this k, since it lies between 2 and 3, numerator is positive. K less than 3, no? Then 3 minus k, what? Positive. Numerator positive, denominator positive, right hand side fraction is positive, therefore L plus beta is positive. Understood? Here, 3 minus k. Here, k less than 3, no. Therefore, 3 minus k is positive. Therefore, numerator and denominator both positive. That means this right hand side positive. That means alpha beta product also positive. So, therefore, summary is alpha beta sum positive, alpha beta product positive. There are two numbers. Their sum is positive, product also positive. What are the possibilities? Therefore, definitely the two numbers should be what? Each positive. Am I correct? There are two numbers. They are sum positive, they are product positive. Then definitely that two numbers should be what? Positive, no? Right? Then we can start to write here. Since k less than 3, greater than or equal to 2, right? L plus beta k over 3 minus k positive, right? Alpha beta 1 over 3 minus k positive. Okay. Sum of two numbers positive, product of that two number positive. That says what? Yeah, each number should be positive. Therefore, you can write alpha positive and beta positive. This is how we take that answer, right? Our next one, show that the quadratic equation with the roots alpha plus 2 and beta plus 2 as roots is this. Right. Now, the equation this has the roots alpha beta. Now asking the quadratic equation with the roots alpha plus 2 and beta plus 2. You know, when I take the two roots alpha plus beta, alpha plus 2 and beta plus 2, you know, these two roots are what? Symmetric roots. What is meant by symmetric? If we replace this alpha by beta, this root come in. If we replace in this root the beta by alpha, this is coming. That is why we say these two roots are symmetric. You know, when the two roots given us are symmetric, to find the quadratic equation, there is a separate technique. What is that? Yes, any root out of these two we take as what? Y. Right? Then we can take let y equals alpha plus 2. Can you remember this method I did in the class? When the two roots are symmetric, any root we take as y. Now after taking like that, this alpha, the root of the present equation, we subject taking this to this side. This gives alpha equals, take this to this side, y minus 2. Alpha equals y minus 2. Now, this alpha is a root of this equation. So, therefore, alpha should satisfy this equation. Then we get what? Quadratic equation in y. That is the required quadratic equation whose roots are this and this. Understand? Right? Go through the notes. This theory available. Right? Now, you can write the last answer like this. Since alpha is a root of 3 minus k perfect, 3 minus k into x squared minus kx plus 1 equals 0, put alpha here. 3 minus k alpha squared minus k alpha plus 1 equals 0. Right. Now, substitute for this alpha, right? What? Y minus 2. Put y minus 2 for this alpha. 3 minus k alpha y minus 2 perfect squared minus k times alpha y minus 2 plus 1 equals 0. Right. Now simplify this. Okay. 3 minus k. Here square this. Y squared minus 4y plus 4. Right. Here minus ky plus 2k plus 1 equals 0. Right. Now we'll collect y squared terms together, y separately and constant separately. Then in terms of y, we get the required quadratic equation. Right. Here you can multiply this and this. What do you get there? 3 minus k y squared. Right. Here we get y term. Here also we have y term. Then what I do is, I take that y term out. Here we have minus sign, here also we have minus sign. With minus sign, we take y out. Then I took minus sign here. I am going to put that y after the bracket like this. Then tell me, when you multiply this and this, we took minus sign and y out. 4 into 3 minus k, we get within bracket. Okay? And here, minus and y, we take out. Then here we get plus k inside the bracket, right? Okay, and after that we have the constants. What are the constants here we have? This 3 minus k should be multiplied by 4. What do we get there? 3 minus k times 4. And some constants come in here, 2k plus 1. 2k plus 1. All right. Now, when you simplify this, you get quadratic equation in y. Finally, this answer is correct. Finally, since the equation asking in terms of x, what we do? Finally, that y later we write as what? X. Then we get the required quadratic equation. Understood? That's how we take. Hurry up. Then we get here 3 minus k x squared, right? You can write in x for y. And here when you simplify, what do you get? Here 12 minus 4k plus k minus 3k. Then we get this way minus 3 times 4 minus k x. Correct, no? Then we get minus 12 we get, and yes, we have to have there plus 3k, no? We get that here. And now simplify here. Here we have 4 and 3 12 and 1 13, then we get 13. And here minus 4k plus 2k is minus 2k equals 0, right? This is the answer, right? This is the answer. Right, no? This is the answer. Right. Now go to part B. Go to part B. Using the substitution, t equals x plus 1 over x. T equals x plus 1 over x. Express the equation this. Right. Right. First of all, shall you square this? X plus 1 over x perfect square. What do you get? T squared. Square this. Multiply this 2 and 2. 1 over x squared. Then we get t squared equals x squared plus 1 over x squared plus 2. This we get. Okay. Now we are given part B, another equation like this. Uh, 6x4 plus 5x cube minus 38x squared plus 5x plus 6 equals 0. Now we'll divide this by x squared. Divide both sides by x squared. What do you get here? 6x squared. Here, when you divide by x squared, we get 5x. Here, minus 38. When you divide this by x squared, we get 5 of x plus 6 of x squared equals 0. Right now? Now, we take this term and this term together. These two terms we take together. And then you can see that 6 we can take out. 6 we can take out. Then we get x squared plus 1 over x squared. Here these two terms we can take together. Take 5 out. Common no? X plus 1 over x. We get. Right. Then minus 38 we have. Equals 0. This is what we have. Then here, within the first bracket we have x squared plus 1 over x squared. You can see people here by this relation. When you take this 2 to left hand side, we get t squared minus 2 is equal to what? X squared plus 1 over x squared, right? Then we can write x squared plus 1 over x squared, right? X squared plus 1 over x squared is equal to t squared minus 2, right? Then I can put here t squared minus 2, here what people? T, here minus 38. Simplify that, you get the next answer, right? Okay. Okay, right? Okay, now 6 times t squared minus 2. Yes, 5 times t, middle term, minus 38 equals 0, right? Remember bracket here, 6 times t squared plus 5t, here minus 12 and minus 38 is minus 50. This quadratic equation in t we get. Okay, right. Now, this quadratic equation we have to factorize. All right, when you factorize this, the two factors come in like this. Uh, 2t minus 5, 3t plus 10. Then one answer for t, 5 by 2, other answer minus 10 by 3. Now we need to find not this t, we need to find x. But we know t is x plus 1 over x, right? T equals x plus 1 over x. Now what we do is this. The first answer of t, 5 by 2, we put here. Then we get quadratic equation in x. So that we get two answers for x. Secondly, t minus 10 by 3, put here. Another quadratic equation come in. For that, another two x values we get. Then altogether there are 4 x values. Understand? Right? Take them. First one, when t equals 5 by 2. When t equals 5 by 2, put that here. 5 by 2 is equal to x plus 1 over x. Okay, no? Now, we'll multiply this by 2x. Multiply this by 2x. When you multiply this by 2x, we get here 5x equals, Here we get 2x squared plus here 2. Then take this to right hand side, 2x squared minus 5x plus 2 equals 0 we get, right? Then factorize this, take two answers. The factors come in like this, 2x minus 1, x minus 2. The two solutions here, x half, x2, right? That is when t equals 5 by 2. Secondly, take t equals minus 10 by 3, right? When t equals minus 10 by 3, okay? Put that where? Here. Minus 10 divided by 3 is equal to x plus 1 over x, like this. Right, now multiply this by 3x. Then we get minus 10x here. Here 3x squared. Here we get 3. Right, no? Then taking this right hand side, we get 3x squared plus 10x plus 3 equals 0. Right, now factorize this. Uh, 3x plus 1, x plus 3. Then we get the next two answers for x minus 1/3 here, x minus 3. All right, there are four answers for the given fourth degree equation. There are four answers. That's how we take the answers, right? Okay, that's the first question. Right, go to next one. Question number 2. You have to quickly write down this n. Again, as homework, you can do this. Right. Right. Take question number 2. It's part A. You are given fx. Fx 2x squared plus 8x plus 13. Express fx in the form of a times x plus b perfect squared plus c. Right? Right. I'll take from the right hand side these two out. From bracket we take 2 out. Then all these three terms we have divided by 2. We get here x squared, here 4x plus 13 by 2. Now inside the bracket we make the completing the square. Can you remember the steps in completing the square? Fx, right, we put a perfect square like this, and this 13 by 2. All right, now tell me the terms we write inside the bracket. From this x squared, without the square, only x, and this x coefficient should be divided by 2. Yes, here we have 4 now, dividing by 2 we get 2. Okay, finally we subtract always what? The perfect square of this, right? 4. This is the way of completing the square, right? Then we can simplify here. If x equals 2 times x plus 2 perfect squared, here what do you get? 13 minus 8. What is that? 5. Here we have 2. Now remove the bracket by multiplying this 2. What do you get there? Fx equals 2 times x plus 2 perfect squared plus 5. Correct, no? Now what is asking there in the question? In the question asking x plus in the form, right. Now I am going to compare this with asking form. The asking form is this: fx equals a times x plus b perfect squared, right? A times x plus b perfect squared plus c. Right. Now compare here. What's a? A is 2. What's a b? B also 2. What's your c? C 5. Right? That way we can give the answers of A, B, C. A equals 2, right? A equals 2, and B also 2, C 5. C is 5. Right? Who didn't get the paper 8? Weekly paper 8? Everybody has. Okay, now what is next one? Asking. Hence find the minimum value of fx. Right. Hence find the minimum value of fx. Now we have fx like this, no? 2 times x plus 2 perfect squared plus 5. Right, you know, for this fx to be minimum, the right hand side should be minimum. But this is a constant, nobody can change it. This also nobody can change. But here we have a variable, x plus 2 perfect square. This x we can change. But x plus 2 perfect square, since this is a perfect square, whatever the value of x, this perfect square is either positive or 0. When this perfect square is minimum only, the fx will be minimum. But minimum value of a perfect square is 0. So once this takes the 0, then we get for the fx from the right hand side the minimum value. When this perfect square is 0, whole thing will be 0, only 5 is right hand side. So therefore fx minimum is what? 5. So clear? Right. Fx minimum equals 5. Right. Deduce that maximum value of this. Maximum value of this. Yes, 2 divided by 1 plus fx. Right. You know, here the numerator, this is a fraction. This is a fraction. A numerator constant. You know, of a fraction, the answer to be greater. Now, for instance, 2 divided by 1, 2 divided by 0.1, 2 divided by 0.01. You can see the denominator decrease in here. Numerator same. When I separately find the answer here 2, here 20, here 200. You can see once the denominator is decreasing, the fraction is what? Increasing. The answer of the fraction is increasing. Like that, for the whole fraction to be maximum, definitely the denominator should be minimum. But if one is constant, nobody can change this. Then to bring the denominator to minimum, this fx should be what? Minimum. Fx should be minimum. But we found earlier fx minimum is what? 5. Then once the fx takes 5 here, what happens? This overall fraction becomes minimum. Okay? Then you can write like this. 2 divided by 1 plus fx becomes maximum. Becomes maximum when fx is minimum. Stop talking, stop talking. When fx is minimum, right? Therefore, you can write the maximum of this going to be 2 over 1 plus fx minimum is 5 here. Here we get 2 over 6. It is nothing but 1/3. 1/3, right? Okay. I will go next part. Right, we are given gx. We are given gx. Gx equals 3x cube plus px squared plus qx plus 7. Where p and q are real constants. It is given that the remainder when gx is divided by x plus 1 is minus 9. Right? This gx is divided by x plus 1. The remainder is minus 9. Tell me in the notation form how to write that. When gx is divided by x plus 1, according to the remainder theorem, the notation is what? G minus 1. Right? G minus 1. Correct, no? Right? This gx function, we divide by x plus 1. Here the remainder is what? Right? Change the sign of it. Put here. This is the remainder. G minus 1. G minus 1 given as what? Right? G minus 1 given as minus 9. Right. Okay, how to find G minus 1? Put for every x minus 1 and take one equation. 3 into minus 1 cube, p minus 1 squared, q minus 1 plus 7 is equal to minus 9. All right, when you simplify this, here we get minus 3, here plus p, here minus q, take this 7 to right hand side, minus 7 and minus 9, minus 16. These 3 also we can take right hand side, we get one equation like this, minus 13, no? Number 1. One equation we get like this. Okay. Next one given this way. When gx is divided by x squared minus 3x plus 2, the remainder is 2x plus r. Right. Okay. When gx is divided by x squared minus 3x plus 2, the remainder is 2x plus r. Now, we can write by algorithm of division this way, no? 3x cube plus px squared plus qx plus 7 is our gx. This is divided by x squared minus 3x plus 2. Right. Right? Then let us assume what? The quotient is hx. Quotient is hx. Right? Remainder given as 2x plus r. Remainder given as 2x plus r. Okay. You know here, this you can factorize. X squared minus 3x plus 2 you can factorize as x minus 2, x minus 1. This way we can factorize that. Correct, no? Okay. How many unknowns are there to find, people? 3 unknowns, p, q and r. One equation we have already obtained, p minus q equals minus 13. Another 2 more we have to take. Now here in the left and right, since this expression becomes 0 when x equals 2 and x equals 1, put in the left and right x equals 1 and x equals 2, then this hx function won't come. Thereby another 2 more equations we can take. Right? Put x equals 1. Here we get 3. Here we get 7. Here we get p. Here we get q. P plus q. Here plus 10. This entire thing is 0. Here 2 plus r. Right. When you put x equals 1 there, finally we get this way an equation p plus q is equal to r on the right hand side, take this 10 to right hand side, minus 8. This is number 2. And next one, put x equals 2. Put x equals 2. Put x equals 2. When you put x equals 2 here, what happens is 2 squared 4p and 2q, right? Here 2 to the power 3, 8 into 3, here 2 into 4, plus 7, 31, right? When you put x equals 2 on the right hand side, this entire thing will be 0, here 4 plus r. 4 plus r we get. Then here we get 4 plus 2q, right? Take this right hand side, r minus 27. This is number 3. Okay. Now there are 3 equations. 1, 2, 3. By solving them, we can find PQR. Okay. Right. First equation is this. P minus Q equals minus 13, number 1. Second equation, P plus Q equals R minus 8, number 2. Okay. Now, how take this? Take 3 minus 2. 3 minus 2. 4p minus p is 3p. 2q minus q is q. This and this we can cancel down. Minus 27 plus 8. What is that? Minus 19, no? This is number 4. Now, how take p and q? At this 1 and 4, q minus q we can cancel down. 3p, 4p, 4p. Here we get the answer. Then we get, by solving this, we get the answers for p8 minus 8, right? Q equals 5 and r also 5, right? I think after this you can solve the simultaneous equations, right? The answers come in. This way we get the answers. Right, using these values of p and q, find the quotient and remainder when gx is divided by x squared plus 2, right? Right, these 3 answers, PQR, now we found. Okay, no? Right. For this p and q, we can write now gx. Substituting for this p and this q, now we can write gx. Right? We can write gx. Right. I write here. Therefore, gx. Substitute for p and q. What do you get there? 3x cubed minus 8x squared plus 5x plus 7. This way we get gx. Correct, no? Now what is asking next? Find the quotient and remainder when gx is divided by x squared plus 2. Right. When gx is divided by x squared plus 2. Right. We'll use the log division method. Right. 3x cubed minus 8x squared plus 5x plus 7. We should divide this by what? X squared plus 2. Correct, no? Okay, can you remember the steps in dividing this? This leading term, we must divide by this x squared. What do you get? 3x cube. When you divide by x squared, what do you get? 3x. Here we must write 3x. Now by that 3x, we should multiply this term and this term. The answer we write below this. Can you remember the steps we did in polynomial function lesson? Right. Then what do you get? 3x and this x squared, 3x cube. 3x and this 2. What is that? 6 times x. Take the difference. This minus this. These 2 will cancel. Here we have minus 8x squared, but x squared term in this line we don't have. Then this one change. Right. 5x minus 6 times x minus x. And this 7 one change. Now we get the new dividend like this. Its leading term is this. That we divide by this leading term x squared. Minus 8x squared should be divided by x squared. What do you get, people? Cancelling this and this, we get minus 8. That only we must write here. Now by that minus 8, we must multiply this and this both and write the answer here. Minus 8x squared minus 8 and 2 minus 16. Now subtract. This and this will cancel. No x later to simplify with this, then minus x will be the same. 7 minus 16 means 23. Correct, no? Then we get x plus 23. Minus x plus 23. Do we divide furthermore? No. Reason? Here degree 1, here degree 2. If we furthermore divide, here we get minus powers 4x. Right? That's why we don't divide. Now we found what? Quotient is this. What? Remainder is this. What's asking? That no? Right. Then we can write quotient minus 12x Yes, quotient is 3x minus 8, no? Yes. Remainder. Right. Remainder minus 6 plus 23. Okay. Now what is asking last? Hence find the quotient and remainder when g minus 2x is divided by 2x squared plus 1. Now here people, we can write this is our gx. Right. Now this gx we can write how? By algorithm of division. What? This multiplied by this plus what? This. Right. Then you can write by algorithm of division. Gx we can write how? This multiplied by this. X squared plus 2 into 3x minus 8 plus what? This. Minus x plus 23. This way we can write by using the algorithm of division. Now what is asking? When g minus 2x is divided by 2x squared plus 1, then what we do? For every x in the left and right, replace x by minus 2x. Every x in the left and right, replace by minus 2x. See what happens? We get here g minus 2x, right here. Every x we replace by minus 2x. Put for every x minus 2x. Minus 2x perfect squared plus 2. 3 times minus 2x minus 8, right? Plus minus x is minus 2x plus 23. This way we have. Now, simplify here. Minus 2 squared is 4x squared plus 2. Here, minus 6x minus 8. Here, 2x plus 23. Right. Now, I take 2 out from this bracket. That by that 2 we multiply the second bracket. Is it all right? I take 2 out from this bracket. By that 2 I multiply the second bracket. Then what do you get there? Here 2x squared plus 1. When I take 2 out. By that 2 we multiply inside the bracket. What do you get? Minus 12x minus 16. 2x plus 23. Right. Here what do you have? G minus 2x. Now what can say? What do you have here? Algorithm of division. How do you explain that? When G minus 2x is divided by 2x squared plus 1, quotient is this, remainder is this. Understand? Right? Then you can write the last quotient. Therefore, the quotient is minus 12x minus 16, remainder 2x plus 23. Okay, right. Right. Right, we'll take the question number 3 to finish this. Take question number 3. Who did question number 3 completely? Yes. Did. Question number 3, who did completely? No one. Yes, right. Right, take question number 3. Yes, you feel these questions are important to you, or these questions are useful? You have something to get by them? These questions, are they too difficult? No, right. Okay, now take number 3. Right, this is write down sin A plus B and cos A plus B in terms of sin A cos A, sin B cos B, right? Right, sin A plus B. Right, tell me what is sin A plus B formula? Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. Secondly, asking cos A plus B. What is the formula for cos A plus B? Cos A cos B minus sin A sin B. Like this. Right, show that number 1, sin A minus B. How take sin A minus B? Yeah, in number 1, replace B by minus B. How take cos A minus B? Here, put for this B minus B, and here put for B minus B. Then we get what? Sin A minus B here, cos A minus B here. Right. Then you can write put minus B for B in above. We get sin A minus B. Sin A cos minus b, cos a, sin minus b. What is cos minus b? Cos minus theta, cos theta. Therefore, cos minus b, cos b. Sin minus b, we told this minus sign we can take out. Then this will be minus. Then we get sin a cos b minus cos a sin b. Here we have sin a minus b. That is okay. Now here put cos a minus b. Substitute for this b minus b, then we get a minus b there. Cos a cos minus b minus sin a sin minus b. Cos minus b is cos b, cos a cos b. Here this minus sign we can take out. That time this will be plus. Sin a sin b. This is cos a minus b. Right. This is the next one. Right. Next one, deduce that sin 15 is this. How take sin 15? We take this formula. Taking this formula, substitute for A 45 degrees and B 30 degrees. 45 minus 30, 15 coming. Understand? Right? And also asking cos 15. Then using this and this, we'll put A 45 and B 30. Understand? All right. Put A 45, B 30. Right. In last formulae. Right. Here. Sin 45 minus B is 30. Right. Here what do you get? Sin 45 cos 30 minus cos 45 sin 30. Yes, what is cos 30? Root 3 by 2 sin 45 1 over root 2, no? 1 over root 2 here, cos 30 root 3 by 2, cos 45 1 over root 2, sin 30 half. Then the common denominator we have 2 root 2 and here root 3 minus 1. Left hand side we get 45 minus 30 means 15. This way. But asking not this one, we'll multiply numerator, denominator both by root 2, right? When you multiply this numerator, these two terms and this denominator, this term by root 2, this root 2 and the multiplier root 2 make 2, that 2 and this 2 make 4. Here root 2 and root 3 product is root 6 minus root 2, right? Sin 15. Sin 15 root 6 minus root 2 divided by 4. Right, now here put A 45, B 30, then we get cos 15. Okay, come to the next one. Here put A 45, B 30. Then we get again cos 15. The second answer you can take, right? cos 45 minus 30, cos A cos B plus sin A sin B. Right now? Here left hand side we have cos 15, cos 45 1 over root 2, cos 30 root 3 by 2, sin 45 1 over root 2, sin 30 is half. Root 3 plus 1 divided by 2 root 2. Then here also we multiply numerator divided by root 2. We get here 4. Right. When this is multiplied by root 2, we get root 6 plus what? Root 2. All right. This is the cos 15. Right. Okay. Number 2, second part. Show that sin 2a equals 2 sin a cos a and cos 2a equals this. Tell me people how to take sin 2a. Here, come to this. Here, we substitute for this b, again capital A. A plus a, we get 2a, sin 2a we get. Then by the right hand side, we get its formula. How to take cos 2a? For this b, we put what? Capital A again. Then we get an answer for cos 2a. Then you can write how? In sin a plus b and cos a plus b, substitute b equals a. Understand? Write down. Put b equals a in sin a plus b and cos a plus b. Right. Sin a plus b is this. Cos a plus b is this. Put the right hand side for capital B again, capital A. Right. What do you get there? Sin left hand side a plus b, no, a plus a, 2a. Right hand side, sin a, b also a, no, sin a cos a. Sin a cos a plus, again, cos a, sin a. Right. This cos a sin a you can write as sin a cos a. Here sin a cos a plus sin a cos a. 2 sin a cos a. Here sin 2a. And in cos a plus b we put what? B equals a. Here. A plus a we get cos 2a. Right. Cos 2a. What do you get there, people? Here a, when you put cos a, cos squared a. Here when you put a, sin a, sin squared a. What do you get? Cos squared a minus sin squared a. Right, we get cos a minus sin a. Cos 2a is equal to cos squared a minus sin squared a. Right, you know, this cos squared a you can write how? 1 minus sin squared a. Right. 1 minus sin squared a. Minus sin squared a. What is this? 1 minus 2 sin squared a. Yes, no? Right. 1 minus 2 sin squared a is the cos 2a. That we get that way, right? Right, deduce that tan a equals this. Right. Okay, the next one, asking to simplify 1 minus cos 2a divided by sin 2a. Right. 1 minus, for this cos 2a, put this 1 minus 2 sin squared a. Right, and this sin 2a, I put this 2 sin A cos A. Remove the bracket here. These 2 we can cancel down. Minus minus plus 2 sin squared A divided by 2 sin A into cos A. 2 and 2 you can cancel down. 1 sin A we can cancel down with this. Sin A by cos A is tan A. We get then 1 minus cos 2A divided by sin 2A. Like this. That is okay now. Now in the last answer, using the results obtained above, show that 7.5 degrees, that before there should be tan. Only in the question that's printing mistake, only this is available. Before that we should have tan 7.5. Okay, right, write down that tan. You got that answer? Yes, yes, that should be 10. Yes, right, okay. Now we start to do that like this. Now we can use this. Tan A is equal to this. 1 minus cos 2A divided by sin 2A. Right, put here A equals 7.5 degrees. Put for A 7.5 degrees. Left and right both. Then what do we get? Tan 7.5 degrees is equal to 1 minus. Right, A 7.5 multiplied by 2. What? 15. Here cos 15. Cos 15 divided by sin 15. People, you know, for cos 15 and sin 15, you took answers. Cos 15, root 6 plus root 2 divided by 4. Sin 15, root 6 minus root 2 divided by 4. We'll substitute that, right? Right, now here, I'm going to write it like this. This sin 15 mean 1 over sin 15, no? Then how take the answer of 1 over sin 15 directly? Yes, in the question we got for sin 15 answer, we take its reciprocal. We'll write directly, no? Here, sin 15 means 1 over sin 15, no? But sin 15 answer we have. Then what is 1 over sin 15? Of the sin 15 answer, we have to take the reciprocal. Sin 15 answer, root 6 minus root 2 divided by 4. Take reciprocal, right? 4 over root 6 minus root 2. Right. 1 minus cos 15. Cos 15, put a bracket 10, right, root 6 plus root 2 divided by 4. This here, right? Okay. Now we can do simplification like this. People, by this 4, we multiply this term and this term. Then this 1 will be 4. Once you multiply this and this, the denominator 4 will cancel what? This multiplier 4. Am I correct? Yes. Then I can write the next line like this. Then once I bring this inside the bracket to multiply these 2 terms, here we have 1. 1 upon what? Root 6 minus root 2 here. Now this is 4 minus when this is multiplied by 4, that 4 and this 4 we can cancel down, root 6 plus root 2, right? Now what I do next is this. this denominator and this numerator, both we multiply by the same value. It won't change the fraction. As my value, I take the conjugate of this. What is meant by conjugate? In between these two terms, the middle sign is minus, no? We convert that to plus. What do you get? Root 6 plus root 2, no? That is called as a conjugate of this. By that, we multiply numerator and denominator both. Right. Then what we get is root 6 plus root 2. Four minus root 6 plus root 2. And divided by root 6 plus root 2 into root 6 minus root 2. People, can somebody tell me the answer for this? Root 6 plus root 2 into root 6 minus root 2. It's like a plus b into a minus b. What is that? A plus b into a minus b is what? A squared minus b squared. Understand? Then how to take the answer? Square this 6 minus square this 2. 6 minus 2. The limit is now 4. Am I correct? Yes, right. Meantime, we'll multiply by this. This term and this term both. 4 times root 6 plus root 2 minus root 6 plus root 2 perfect squared. Now denominator we have 4. All right. Now the last step. Root 6 plus root 2. Right. People, here what again? This is like a plus b squared. A plus b squared. How to take? A squared 6. B squared 2. 6 plus 2 is 8. What middle term? 2 into 2ab, no? 2 into root 6 root 2. Root 6 root 2 means root 12. 2 into root 12. We get this, no? As a middle term. Right. This 12 we can write how? 4 into 3. Root of 4 is 2. Then we can write this as 4 root 3. Am I correct? Huh? Yes, right. 8 plus 4 root 3. Whole thing divided by what, people? 4. 4, right. Then take 4 out from here. Cancel down with this 4. 4, you can cancel down with this 4. Here we have 2. Here we can cancel down. Then we get the answer, no? Root 6 plus root 2 minus root 3 minus 2. Answer coming. Right, no? Right. This gives us the answer. Root 6 minus root 3 plus root 2 minus 2. Right. Who got this answer? Right. Good. Okay. Good. Right. Right. This is the end of the discussion. Right. 1 hour 15 minutes. Only 3 questions. But remember, people, this kind of questions, if you are okay with this kind of questions, right, you can go through the past papers. In the past papers also, similar type of questions available. Right. Okay. I'll take it.